welcome to the video for identifying key features of linear functions. The goal of this video is definitely to get over this fear, because I know some of you are thinking, equations, tables, and graphs, oh my. But after the video, we're looking for you to meet some objective with analyzing graphs and tables, being able to even create a graph and even calculating the slope. Now, equations, there are a direct approach. And I know one of these a lot of you are very familiar with. Can you guess which one? If your eyes are drawn to this first one, y equals mx plus b, that is a good idea because that is that slope-intercept. And most of you are commonly familiar with that linear model. But you also have the point slope that you may have used, and then the standard form. And each one has this particular usefulness when you're creating linear models. Now, for the direct approach, there are some pros and cons when we are looking at the linear models. Now, it can easily find exact values when you're working with an equation, and we can easily update it just by changing the numbers, and we can transfer the information easily between the different approaches we're going to talk about. But one thing the linear model does not, the direct approach does not do in the linear model is it does not give us a visual representation of the model. So that's where we'll look at some other approaches for that. One is the organized approach. And one of the organized approach could be the table. Now the table again has some familiar pros. It does give me the ability to find the exact value. I can easily update the numbers in the table, but without the linear model, I'm unable to change the values unless I'm told exactly which one to change. So there are some drawbacks to having a table. And then our other third approach that we talk about in this video is going to be a visual. As you notice, it is easy on the eyes. It gives us a direct look into the visual relationship between a linear model. And also, not too foreign to you is the domain and range, which I can identify here because it is a linear model, that both my domain on the x is all real numbers as well as my range on the y is all real numbers. But unless I scan in on this line, it's pretty hard for me to see the exact value unless I go directly to my independent, my dependent. And it's hard for me to make the change without the linear model. So there is a pros about having a visual look into the linear model, but it does limit me on finding the exact values. So let's work with each of these approaches when we're talking about a linear model and making it from the example. Let me give you a moment to go ahead and read this. From your reading, I hope you're able to see that we have 3 individuals who are looking to make a trip after graduation. It could be high school or maybe even an undergraduate where they want to Bahamas before they get a real job. And they want to take a big trip together, but they want to make sure they are planning that trip. So they does have a plan that accommodates some combined savings that they have, and they're going to be working together on a monthly basis to meet their goals. So Luke, Deborah, and James are working on this agenda. So let's help them with determining their variables. So we talked something about domain and range. Well, for our first one, our domain is definitely dealing with our independent variables. And since they're going to be working together for 4 months, 3 friends, we're going to use that as our independent variable. And our range was definitely going to include the outcome of what they're going to be doing, which is they definitely need money to go on the trip. So dollars, and we're going to focus on US dollar here, is going to be their dependent variable. So let's create an equation for the 3 friends in order to help them with their saving plan. Before that, we also want to start with creating our form. Again, my eye still goes back to that slope-intercept. Yours may too, but if you're comfortable with a standard or point slope, we can definitely rearrange it. But for this video, we're going to stick with the slope-intercept. So when we're focused on the slope-intercept, we're going to stick with that format y equals mx plus b. I'm going to go back to our problem statement to pull out the information needed. Now there are 3 numbers in here, and we have 4 variables. Let's see how those 3 numbers help us with creating a model. So let's start identifying our key features. Well, we know we have a slope and our intercept. that needs to be pulled into this equation. So starting with the slope, we're going to look at something that changes. Well, we know our month is one of our independent values, but doesn't give us any additional details to help us with attaching it to the slope. Well, if you pinpoint your eye on the word additional, as I said earlier, it does. There is additional $300 that they're going to be working with each month to save. So I'm going to pull that in as my slope, and I'm going to insert it right before the X, because remember, M is a letter that does represent slope. So now that leads me to my intercept. Now, intercept is something that we started with. And we know the group had a combined savings. And we're going to attach that to our y-intercept. So our combined savings and our y-intercept is going to lead us to our b value. And we're going to put that in as 1,200. So we did a quick substitution for our variable b at 1,200 since that is our y-intercept. And if you notice, I have my linear model, but I didn't use all three numbers in my problem statement. Do you know why? Remember, my x and my y are my independent and dependent variable. So those in linear model are going to stay as variables because it's going to tell me what they're going to do and then what they're going to get by their actions. Now our equation is created. We have our linear model with our key feature of our slope and our intercept substituted in. Great job. Give yourself a round of applause if you are definitely grasping along and creating your linear model. So let's move into our organized approach with the table. Now again, we are going to stay consistent with our independent variable x and our dependent variable y. And we're going to start our table off with our combined savings because that is our starting point. So that's going to be indicated when x is 0. So always remember your y-intercept, the x has to be 0. So let's see, can you go ahead and populate the next line of the table? Well, we know they're working on a monthly basis. So in the next month that they're working together, how much as a group will they have? Well, we're going to look at that initial amount of $1,200, take into account that next month they're going to save $300. Remember, it's an additional $300 a month. I'm going to take the sum of that, and I'm going to end with, yep, that is $1,500. So I know in month 1, the group will have $1,500 in order to save for their planned trip to the Bahamas. And I will do that consistently for each of the months listed because remember they want to go in the next 4 months. So now we're on to our last approach, which is our visual, and that is definitely dealing with a graph. Now before we can create a graph, we want to ensure that we have a scale to make sure our graph is readable. We're still going to use that same independent variable of x, but we want to make sure that since we're dealing with the next 4 months, that we just increment it by 1 month, and that should be okay for us to really show the model on the graph. And dependent, well, I do want to look at the amount that they started with and what they're doing each month to ensure I have a good range for my y value, my y-axis. So let's kind of go with the increments of 500. It should be okay there. Voila, we have our graph created with our months, which is our independent variable on the x-axis, and our saving, our dependent variable on the y-axis. And see how we're incrementing by 500 and we're incrementing by 1. And if you notice, our scale on the x and y does not need to be the same. It just has to accommodate the values in the domain and in the range. So just make a mindful note there. They do not have to be the same, just have to be accommodating. So now that we have our graph created, we not only want to create it, we actually want to check it. So let's look and see that our graph started where it's supposed to start. So I know my initial amount, as indicated, should be 1,200. Did this graph start at 1,200? Well, yes, it did. If you notice right here, the starting point of this graph is right there in between 1,000 and 1,500, And remember, I can't get exact sometime on the graph, so I'm estimating that this is probably at about 1,200. So I definitely check my starting amount and my y-intercept. So let's go in and check our average rate of change, or commonly known as slope. So I'm going to pick 2 points, and since we already verified the initial, let's start here, and I'm going to check, did I rise correctly, and did I run correctly? And mind you, my lines are just a little bit off, and that's one thing with graph. It is kind of about graphs. It is hard to get the exact, even when you know what you are working with. So there we go. So I know that my slope said I should be at $300 a month. So I'm starting here at $1,200. It looks like I went up to $1,500. And yep, that is a rise of $300 and a run of 1. Now, mind you, this is not drawn to scale because the 1 sure looks a whole lot bigger than the 300. But remember, our scale is accommodating the increments that fit for both the domain and the range. So it is not drawn to scale the increments. Just remember, it's just accommodating. And that average rate of change keeps picking up. Remember, that is the formal way of seeing slope, but we do still use slope as well. So now, going back to that table, we did check that it had the correct initial value, but did we go ahead and check the average rate of change? We actually didn't. Go ahead and see if the table is correctly showing the average rate of change, or as you commonly know, the slope. Well, if you are looking at, and if you recall, remember the average rate of change is the same thing as saying a y2 minus y1 over x2 minus x1. And that latter in that linear model is m. So we're going to check to make sure the difference between the y's and the difference between the x's are definitely at 300 over 1. So let's check the first set. Yep, I go from 12 to 15. We did check that one earlier, because that's what we use. So that's 300 over 1. So let's check the next pair. That is also 300 over 1. So now you check the next two and see that we are in that same rate of change or same slope as followed throughout that table. Well, the next one did follow suit. But looks like there is a problem. The last one only went to 200 rise instead of 3. So there is an error in this table. And remember, in a linear model, we want to make sure that the average rate of change or slope stays consistent throughout the table. So there is an adjustment that is needed here. So we're going to go ahead and draw a line through it. Remember, if this was not on the computer, we can easily make that change and change that to, instead of 2,300, 2,400, so that I do show that average rate of change of 300 instead of 200. So that's the way in order to check your table and your key features. Remember your initial value, and then your rate of change does have to stay consistent throughout. So in the video, we have gone over the 3 different approaches. Some of you may have one that is you're more partial to, which is okay. Depending upon the scenario and how it's asked, either one may be suited in order to solve. Remember, the equation is your direct approach. The table is an organized way to do it. And the graph is definitely a visual model to easily see that the relationship is linear. So by using each of the 3 and going through the video, you're able to identify the key features and your linear functions, and you've created a tables and graph. Now, was that so hard? Well, I hope you enjoyed the video and look forward to you using it in order to assist you with linear functions and identifying those key features. Thank you.